You're listening to the Curious About Cannabis Podcast. One thing I want to make sure we spend some time on talking about is, I think a question that's on a lot of people's minds that are in the cannabis industry is, how does a lab know that their results are accurate? Because it's pretty well known at this point that depending on what lab you go to, you can get very different results, especially with potency, and that's kind of its own issue. But even with things like pesticides and things that really affect public health and safety. So can you talk a little bit about what labs do to prove to themselves that their own results are accurate, and then stemming from that, what consumers can do to kind of evaluate labs so they can trust the results they're getting?
Sure, absolutely. It's a subject near and dear to my heart. I guess I'll maybe answer that a little bit in reverse, is that, as a consumer of what labs have to offer, if you're a cannabis or hemp farmer or manufacturer, one thing I always encourage people to pay attention to if you're shopping for labs or meeting labs is, you really should be looking for a lab that you can have as a business to business relationship with. And that would begin by, when you tour a lab, or even talk to their principals, on the telephone, like, there's no black arts in a laboratory. And so there's no like secret curtain.
Yeah.
There's honestly nothing super proprietary.
Right.
Or, there's a lot of high tech stuff. And what we do is tedious and difficult. That's why everyone doesn't do it. It's not because it's, magic or proprietary. Yeah. And so, you should get that feeling when you go to a lab, like, these are our instruments. These are our trained staff. Here are some of our, records. We make data in a process. And just like if you have a factory full of robots and machines and humans, in order to get that factory output right, there has to be a lot of traceability and a lot of control and a lot of communication. And these are the same sort of things. I don't say data factory because we don't actually manufacture data, but the word for it in the lab space is that we do data realization. Okay, so data realization is not squirting stuff into machines and then issuing PDFs to people. It's a tedious process that has tons of built-in traceability and controls and checks. And when you go to a laboratory, quality should be visible. The lab should be clean. It should be organized. The people, should be wearing what you would consider typical laboratory lab coats, gloves, eye protection, things like that. So that they're serious about their profession. There should be training manuals posted. There should be logs, logbooks next to things like scales and instruments, right? Those are some of the early signs that there maybe is quality happening in the lab. Beyond that, what we're doing in the lab, in the back, if you will, I had mentioned traceability. So traceability is a very, very important part of quality assurance, in manufacturing, but, especially over here in doing lab work too. And what we mean by traceability is that, businesses and regulators do stuff with our data. That, our data validates that materials are okay for commerce or public consumption. Right. And so that data, when it goes out into the world, as an ISO and ORLAP accredited laboratory, we need to make sure that all of the reagents and chemicals that were in the laboratory that went into making that data happen, that they're validated and we know where we got them,
they're pure,
and that they're pure. Similarly with the humans that touch samples and computers and instruments, we have to have traceable records that the people that participated in data realization are trained to the latest procedures, that we've done what we call demonstrations of capability. They're sort of like bench checks of their precision. Similarly, that there's records that instruments are calibrated, and that any certificate of analysis that we put out there, if any of that information is ever in question, we can do a quick audit and tell you every person who was a part of the data realization process, every batch of chemicals and standards, every instrument and what its status was. Yeah, so traceability goes the other direction too. So I just described how we understand everything that goes into our certificates of analysis. But imagine a case where one of our vendors calls us someday and, we had an accident in the lab and we shipped you this chemical or that solvent, and it was the wrong stuff or it was the wrong purity.
Yeah.
We have to now go and look forward into any data that we've realized with that material, right? So it's traceability in both directions, and that's pretty much the foundation of how you manage quality. Is one, understanding everything that goes into your process and
being able to trace it back. Yeah.
Another part of quality and what you should be looking for is a lab should be doing what's called proficiency tests. There's an array of formal and informal ways to do that. We do both. Our laboratories participate in third-party external proficiency tests. So these are chemistry and biology companies that provide benchmarked, standardized material that they will ship to a lab, and you are blinded to the quantitative amount of analytes that are in it, but this is a cannabinoid proficiency test, or this is a
what to test for
pesticide proficiency test. Yeah, and so in the pesticide proficiency test, we'll receive like ground hemp, or sometimes it's made in the state. So sometimes it's ground cannabis, and then we get a vial of liquid, which contains an unknown amount and quantity of pesticides, which we're required to spike on there, perform our assay, and then report those qualitative results back. And, you either pass or fail, right? You have to get all the analytes. Generally, these studies are done with groups of labs. So you have to be typically within like one standard deviation of the actual answer. So a lab should, a lot of labs are actually required to do PT tests. But it should be something the lab is proud about. And you should definitely ask your lab about how they do their PTs and when and how they perform. That's the primary external benchmark that we have for what we call accuracy.
Yeah, you don't want to run into a lab that is nervous about sharing their participation in a PT.
Yeah, absolutely not. I don't know why you would want to. They're hard to accomplish, and it's really like the only external thing that we have.
Yeah.
We do a form of internal PTs, like between our own laboratories, but also with collegial, competitor laboratories.
Kind of a more casual round robin type of.
Exactly. We'll agree on a way or a method to produce some homogeneous material, and then distribute it amongst our different labs, and then compare the data for our own purposes. And that's a good way to actually quantitate what we call, calculation of uncertainty. Uncertainty, it's a statistical term, and it's sort of it's roughly a balance of a measurement of your accuracy, but also precision.
Right.
And precision is something a little different, but also important. So when you just do one test on something called a PT, you're either accurate or you're not.
Right.
That's a
You
shot
either
on
hit
target,
the target or
and
not.
you hit the target on the bullseye or not, or
Yeah.
some distance from it, which is acceptable or not. Precision would be something that we generally measure in-house, and it would be a repeated preparation and measure of the same thing over and over. And it would be for the goal of measuring the precision, maybe of a trainee or a technician, but it also can be a measurement of precision of like an instrument.
Yeah.
And also just the overall process. A lot of times we'll do precision measurements by having, like I mentioned, a trainee prep 5 or 10 of the same exact thing and then measure them on the instrument and see the difference. But then we'll also have that done on different days at different temperatures and
get a full sense
see what kind of variation happens, not just from the technician's thumb, but also from the instrument and the whole environment of the laboratory.